Okay, question 1J. Let n greater than 1 be an integer. Let big pi of n denote the number of distinct prime factors of n, and let small x of n denote the final digit of n. For example, pi of 8 is 1, and pi of 6 is 2. Which of the following statements is false? Okay, so here we're trying to, find a false statement, right? So let's try to understand the question first. When pi of 8 equals to 1, why is that so? Well, because 8 is 2 cubed. Yep, so there's only one distinct prime factor, so that equals to 1. And how about for 6? 6 is 2 times 3. So 2 distinct factors. Okay, so let's have a look then. So let's look at statement A first. If pi n equals to 1, there's some values of xn that mean n cannot be prime. Okay, so we're going to try to find a value of xn, such that n cannot be prime. Okay, so how can I prove that this is true? Right, now this is easy to prove true because there's some values, right? So I just need to find one, right? Which means that xn cannot be prime. Well, for example, why not choose 8, for example? Yeah. Now, if pi of n equals to 1, well, 8 is okay because 8 is 2 cubed, right? Now, you could find something else which also ends in 8. Well, I don't know what you would find, but it doesn't matter what you find. You could, for example, 8 to the power 5, for example. I mean, that's like 2 to the 15, right? Okay, this is also, if you take pi of this is also 1, right? Because 2 is the only factor, and it still ends in 8, right? You know that the only even prime number is 2. So anything which ends in 8 can never be a prime, right? So A is true, right? For example, if I take x of n is 8, then n cannot be prime. So that's correct. All right, part B then. If pi of n equals to 1, there's some values of xn that mean n must be prime. Okay, so now let's work our way through that. We've got to check, right? We've got to check that this is we're going to check this is true or false. So, well, let's start from x of n is, say, 1. Okay, does that mean that it must be prime? Well, not really, right? Because you could find a counterexample easily, which is, for example, 11 squared is 121, right? This is definitely not prime. Okay, so the general strategy actually is to think about, when you multiply by numbers, think about the final digit only. This final result doesn't matter at all. Yeah, think about the final digit only. For example, x to the n equals to 2. Now, then you think to yourself, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 ends in a 6, 6 times 2 ends in a 2 again, right? So you could just pick 2 to the 5 and then you're done, all right? Because this means that it's not prime, right? 2 to the 5 is not prime. Okay, so 2 is not a candidate either. Okay, how about 3? Again, you've got to think. 3 times 3 is 9, 9 times 3 gives you a 7, 7 times 3 gives you a 1, 1 times 3 gives you a 3. Okay, if I pick this, 3 to the 4, then n is not prime again, right? N is not prime again. By the way, these are values of n that I pick, yeah? Same logic, you could work your way through now, right? X to the n is, well, I don't know, what do you fancy? 4, say, right? Okay, 4, and then you just go 4 to the, doesn't even matter. 4 cubed, for example. Now 64 straight away. Yeah, I'm going to do the same procedure for the rest. 5, you could just simply take 5 squared. 6, I think 6 squared also works. Yeah, 36 is all good. Again, 7. If x of n is 7, what do we have? 7 times 7 is 9. 9 times 7 is a 3. 3 times 7 is a 1. 1 times 7 is a 7 again. So just take 7 to the 5. Again, if x of n is 8, I'm just continuing the rest. 8 squared is no good. 8 cubed ends in a 2. 8 to the 4 ends in a 6. So 8 to the 5 should work. Yeah, as I just said in part A, really. And xn equals to 9. And, same logic. 9 squared just gives you a 1, so 9 cubed will be good. Yeah, if xn is 0, I mean, that's just simple. Just use something like, 10 and then squared, and you'll be fine. Right? You use something like 10 squared, you'll be good. Okay. So, there you go. That means that all of the value of n's, all of the values of xn, does not mean n must be prime, right? I've found all the numbers for each digit where things are not prime. Yeah, so B is false. All right, so if B is false, we could choose that as our correct answer, and we need not look further.